Hello, this is Ray, one of the program presenters in the Atchison Planetarium at Cranbrook Institute of Science, with a look at the pre-dawn sky for the week of May 3rd. Our morning sky is still dominated by the planets Jupiter, Saturn, and Mars. Jupiter is brightest in the south-southeast. To its left is fainter Saturn, and in the southeast is Mars. To the left of Mars is a faint constellation of Aquarius. It's one of the oldest constellations known to the ancient stargazers. It's known as the water bearer because its appearance coincided with the rainy season. It's from Aquarius that the Eta-Aquarid meteor shower will radiate before dawn on May 6 and 7. The Eta-Aquarid is an above-average meteor shower that produces about 30 shooting stars per hour. It's caused by the Earth passing through a stream of debris from Comet Halley. This is a better shower than last week's Lyrids, but the moon is nearly full now, and its light will brighten the sky, making it difficult to see fainter meteors. Meteors can be seen in any part of the sky, but they'll appear to radiate from Aquarius. Aquarius rises in the east-northeast around 4 o'clock in the morning, but meteors can be spotted from midnight to dawn. While you're out stargazing, face south and look nearly overhead before dawn. Notice a bright blue-white star Vega. To the right is a faint constellation of Hercules. It's marked by 4 stars forming a keystone. A keystone is like a square, but it's narrower at the bottom end. Located down the western side of the keystone is the spectacular Hercules globular star cluster. It's one of the finest globular clusters in the sky's northern hemisphere. What is a globular cluster? Globular clusters are dense collections of stars. They're spherical in shape, and there can be hundreds of thousands, sometimes millions of stars in just one cluster. The Hercules cluster is estimated to contain 100,000 to 300,000 stars. Its diameter is roughly 160 light years. To put that in perspective, you'd need to put 768 of our solar systems end to end to span that distance. There are about 150 globular clusters in the Milky Way. They contain some of the oldest stars in the galaxy. The age of the universe can be estimated by studying them. Most are believed to be at least 10 billion years old. Globular clusters form from huge concentrations of gas that collapsed due to gravity. As the gas is compressed, stars are formed. Well, that's how planets form as well, but globular clusters are not favorable locations for the formation of solar systems. But what keeps gravity from squeezing all the stars together in the center? The same thing that keeps our planets from being pulled into the sun: motion. The cluster and all the stars within the cluster are in motion, just as the planets are in motion around the sun. Each cluster moves as a single object within the galaxy. Individual stars in the cluster move around randomly. Gravity holds the cluster together so the stars go flying off into space. Globular clusters also rotate. The Hercules cluster was discovered by Edmund Halley in 1714. Yes, that Halley, who predicted the return of the famous comet that now bears his name. He wrote, "This is but a little patch, but it shows itself to the naked eye when the sky is serene and the moon absent." Unfortunately, the moon isn't absent in the morning sky this week. Between moonlight and city light pollution, you'll need binoculars or a telescope to spot the cluster. Even a small telescope will show it as a fuzzy blob of light. The Hercules globular cluster is also known as Messier 13, or M13. Charles Messier was a comet hunter in the 18th century. He occasionally came across faint, fuzzy objects that didn't turn out to be comets, and he compiled a list of them. So, 50 years after Halley's discovery, this cluster became number 13 on Messier's list. Remember the Ring Nebula from last week? That's number 57. In 1917, astronomer Harlow Shapley calculated the distances to many globular clusters and used that to determine the size of our Milky Way galaxy. It turned out to be much greater than was believed at the time. Globular clusters are located on either side of the galactic plane, and Shapley used them to determine that the center of our galaxy is located beyond the constellation of Sagittarius. That location is a little to the right of due south at 5 in the morning this time of year. The moon will be near that location on the morning of the 10th. In 1974, the Arecibo radio telescope in Puerto Rico beamed a message toward M13. It provided information about humans, the location of Earth, and other data. Unfortunately, the message will never get to M13. By the time it arrives, 25,000 years from now, the cluster will have moved around with the galaxy and be located in a different part of the sky, and we will be past the point of caring. The full moon on the morning of the 7th is considered by some to be a supermoon, because this full moon phase occurs when the moon is close to Earth. Its orbit will bring it within 244,000 miles. That's not exceptionally close, but the moon will be 7% larger and 15% brighter than average. That won't be perceptible to the naked eye. The exact time of the full moon is at 6:45 in the morning. The moon sets at 6:40 on the 7th, and the sun will be rising 15 minutes before moonset. On the morning of the 8th, the moon is located to the upper right of Antares in the south-southwest. Antares marks the heart of Scorpius the Scorpion. The following morning, the 9th, the moon is at the upper left of Antares. The distance the moon travels from one day to the next is very apparent when you compare its position to a nearby bright object. Next week, the moon will pass Jupiter, Saturn, and Mars. The sun continues to rise earlier each day. Sunrise on the 3rd is at 6:25. By the end of the week, on May 9th, sunrise is at 6:17. Thank you for visiting, and keep looking up.